Okay, objective.
Right.
Be able to plot the points, make space, of ordered pairs for a linear function. That's not very well written, but you get the idea. Plot the points of ordered pairs for a linear function. You get it there. That was good. Okay. So what we need to know is, what do I mean by ordered pairs? That's a question. We need to be able to plot them on a Cartesian axis.
Did you use your writing board?
No, I'm just typing. It's nice, it's different. Okay, plot them on a Cartesian axis, and then we need to be able to recognize a linear function. Okay? Okay, guys, so what we need to be able to do is understand what we mean by ordered pairs, plot them on an axis, which I think we already know to do with coordinates and things, and recognize a linear function. So, I want to set this up first. So, on your bit of paper, which looks like that, right, we've got a function. Now, we've got a function that looks something similar to this one that I'm going to write. Okay? Now, do you remember from before what this means?
Yeah.
What does it mean?
So y equals the gradient, and then how many steps it goes up in?
No, not
no,
quite. You're actually going further on than I wanted at the moment. But yeah, you're talking some things to remember, like you said, are gradient and the y-axis intercept. But we're not going to talk about that today, but that is something actually to remember. I'm going back to a little bit more even basic than that, just to remind us. Basically, what this means is we have two numbers that are yet to be found. So basically, we have x, which is called a variable because it changes. Okay, and what we want to do is put this value x into what's called a function, right? And a function is something that you do to x, so you do some maths to that number, and you obviously get an answer, and that answer we call y. So we have an input variable, and the output is the y value. Now it could be any letters we like, but we use x and y, especially when we link it to a graph, because
it's x and
we have x and y axis, so it's just one of those standard things we do. So if we have an input going into a function to give an output, right, the function is the set of mathematical operations that we have to do. So we have to write that in a certain way, and that's what this equation is about. So do you remember what this equation means you have to do to x? So, anyone? Plus 5 is part of it. Yeah, so definitely plus 5 is part of it. Right.
The variable.
What's the other thing though? What's this 2?
2 times 2 plus. Then you add it together and it's the Oh wait, wouldn't is it like if it was 2 x's, when we do it like?
So what did you say? If it's 2 x's?
Yeah.
So if we take x,
no, it was like x.
What do we do first? If we say 2 x's like you just did, what does that kind of make us think about we have to do? How do we get 2 x's? If we start with 1 x, we
add
we can, but another way of adding another one of the same thing is to times good by, if I want 2 of them. Yeah, so here look, so if I want 2 x's, I need to times by 2. So that's the first thing I need to do to it first, right?
Oh, and then you add 5.
And then whatever that answer is, we get an answer, an intermediate answer. So whatever it is, then whatever that is goes
Plus
into a
5.
second part, which is, you're right,
Yeah.
plus
And
5.
then it equals something x.
And then it equals something,
Yeah.
which we call
An output.
y.
And y.
That's what y will be.
But like, yeah, but y will be a number.
Yeah, exactly. So now, for instance, now we've set this up, we understand what this means. We can now start thinking, well, what if I would stick any number in? So let's stick a 3 in. Okay. First of all, I have to do times 2. So I do 3 times 2, which equals what?
3 times 2 is 6.
So 6. So this intermediate bit here is 6. And then that goes into the next bit, which is plus 5. So I have to do 6 plus 5 makes 11. So in this case, what I can say is, when, that's a good question, would it be 11y? Well, actually, y is 11. That's what we're saying. So what this means is, when x is 3, y is 11. So these are what we call a pair, right? The pair of numbers that go together, but only with this function. If I change the function, that x will not give that y. Make sense? So we can do that with any number I like. So if I stick 5 in, what's the intermediate step? Jaina?
5 times 2.
Good. So 5 times 2, which equals 10. And then that goes into, so we get 10 plus 5, which will make 15. So the ordered pair is, when x is 5, y equals 15. Yeah?
Oh, but it's like, can't you like figure out the pairs without having to do all that? Like, because 5 is, can you not do a calculator?
Sure, I mean, there's lots of ways that we could go, but we have to kind of, first of all, get, well, how do we link those two numbers? So when we start looking at the graphs and things, then yes, there's other ways to do it. And that's what we want to get to. We want to have a greater understanding of, the function, what it looks like when I put all those points on a graph, and so on. So what about if 0 goes in? So, Sophie?
It will be 0 times 2.
0 times 2,
0.
which is 0.
And so
that answer goes
then
into...
it will be 0 plus 5.
Yeah.
Which is 5.
Which is 5.
So it will be x equals 0 with y equals 5.
Good. Okay.
But how do you know it's always times 2?
Because that's what we've been told to do.
Oh, okay.
Yeah? Up here. Alright? Now, there's probably a better way of displaying this. And actually, we want some kind of system as to which numbers I'm going to pick. So, what we do is this. We set up a little table and we say, right, when x is what? So, pick some numbers. I'm going to go -2 and then count -1,
7,
0, 1, 2, 3.
4.
I can go as far as I like. I can pick other numbers, but I picked a nice set of what are called consecutive numbers for x. There's no reason why I picked those other than I want to check your ability with negative numbers. So don't worry about the x values that we choose. But then what we have to do is we have to figure out the y values. And what we would do then is have a table of values created. Yeah, you can write this down. So we would create our table of values. We're back recording. So we've got these tables. Now these x values are just like these x values. So actually, I can put this 3 here matches with 11. So on this table, I can put 3 matches with 11. So 11 can go in the table. So here is the pair of numbers. The 3 goes with the 11.
The 0 you can put 5.
Good, yeah. 0, we can put a 5.
Wait, I did that wrong everything now.
Okay. Doesn't matter if you've got a gap, so
You can't.
no, now there's no others. But we could work out a couple. So why don't we have a go at working out either... Yeah, let's have a look at 1.
Oh, yeah.
So, should we do it without writing things down? Let's see where... So we have to do 1 times 2 is...
2.
Plus 5?
7.
7. Okay, so 1 goes... And here is where you might spot something from before.
9.
Janus.
9.
Yeah,
It's
Janus.
plus 2.
So it's always plus 2. So we've got 9 and 11. So you were saying, is there a quicker way of doing it? I think you remembered that. So 4 will be 13. Minus 1 will be 3. Minus 2 will be 1. Okay. Now what does that match with? This, as we move up, is plus 2. Do you just see whether you remember? We don't need to talk about it now, but see whether you remember. How does this number match with the function? Because it's 2x, yeah? That helped us with the plus 2 bit. Okay, so that's something to remember. Right, however, what we're going to do is we're going to look now at, if we get a table of values, what do we then do with showing it on a graph? So I'm going to get you to do... Well, let's do another one of these first, a different function. So looking at your sheet, we've got this, look. So we've got 3x minus 4. So that's the one that we're doing this time on your sheet. I want you to fill out these tables with the pairs.
But we have no headers.
Pardon?
We have it's the same as the ones there, right?
Well, it's only minus 1, 0, 1, 2, 3, and 4. And it's a different function now.
So it can't be the same answers. No.
Oh, no, it won't be the same answer.
Can't.
Now, there was one other thing up here, look. I don't know whether you remember how to start this table off really quickly. Did anyone remember if this is plus?
It kind of rings a bell.
If this is plus because it goes up in 2s because of that 2, do you remember anything that goes along with the plus 5? If we look at this table we did.
No, I remember it rings a bell.
Is there any 5 in there?
Oh, 5 is 0.
5 is with the 0 level.
That's what my dad told me.
Is
5 always 0 then? So
No.
4 is 0.
No, careful. 0 is what in this case? There you go. Minus 4. So we should check really. 3 times 0 is 0. Minus 4 is minus 4. Now, what are they going to go up by?
Please.
Go on then. You do it.
I get confused by negative numbers.
Okay, so we've got some answers. So we reckon that because this is 3, that it's going to go up in 3s. So you just have to be able to count up in 3s.
You can't even see what.
So minus 4
Minus 1.
plus 3.
Minus
We go that way. Should be minus 1.
2.
Then we go up to
2. 5, 8.
5, 8. And then this
7.
one, negative 7. Good.
Now we plot them.
So now we plot them.
But we plot only the negative 7 and 4.
So we've got to do now this is where the pairs come in. So coordinates are x, y. We did that before. So this coordinate, for instance, is what?
Oh yeah.
Minus 1, minus 7 is a coordinate. So on here we've got minus 1 down to minus 7. So it is quite difficult. So it's there, isn't it? Yeah, it's a bit difficult.
0.
I'll just zoom out so we get it all on 1. So 0.
Oh, I'm pretty sure it's going to be a line.
I think you're right.
Yeah, I'm done. It's a line.
0 minus 4.
Can I connect them?
Yeah, if you want to connect them. 1 minus 1. 2, 2.
2, 2.
3, 5. And 4, 8. And yeah, like you say, we should be able
And
to
now
go.
here you find the gradient.
Now we should be able to do.
Oh yes! I remember. When it gives you that, you have to find out the...
Well, we actually already know the gradient, don't we? We actually already know the gradient, don't we? Do you know why we know the gradient?
Yeah, because y equals 3x. I don't know which one's the... I don't remember anything.
Well, actually, what is the gradient of this line then? How do we work it out?
3.
It's 3, isn't it? So it's across, because it's across
Yeah,
1,
it's
up,
across 1, 3.
so it's plus 3 when we go across. So what do you notice? The plus 3 is the gradient. And if that plus 3 is plus 3 because of this, what's that number?
0.
No, what's the 3?
Gradient.
It's the gradient. So that's the gradient. And then you notice how the 0 minus 4 bit, okay, 0 minus 4, that one, is this point, which is the
Starting point.
or more appropriately called, if you remember back up here. So we've got
The
gradient
variable
and the
intercept.
y-axis intercept, yeah?
Wait, can I just write this?
Wait, isn't that?
Gradient and y-axis intercept. So maybe on your graph,
Yeah.
right? So
Wait,
we
y
do,
equals 3 minus 4.
so we've got the plus
So
3,
We
we've
know
got
that
as the
'cause
gradient.
We know that because it goes up like that. 1, 2,
Minus 4.
Exactly, perfect what you've done there, yeah, brilliant. So the plus 3,
Oh.
so yeah, I'm going to do it a bit different colour for you. So yeah, if we go across 1 and we go up 3, okay, that's how we see it.
And then this is the y-intercept.
So this point here,
Oh, wait, it's when the something and something meets.
Yeah, it's when it.
yeah, so an intercept is when they meet, so it's when the graph cuts the y-axis. And then
What?
this, what they go up each time, is the gradient.
Oh wait, are
Quite
we
hard.
still to that?
Yeah, you can see that. Definitely. Okay with that? So has that reminded you of what we did before, yeah?
Totally.
Totally. So we've got
Totally.
gradient and intercept. Now, by making all those links, the next time we see a graph or we see a function, now, do you realise that all of this stuff, the function, the pairs of numbers, the table, the coordinates that we decided to start using, and the graph, it's all the same thing. It's just different ways of writing. So all three have, you can find the gradient from them, right? And all three ways you can find the intercepts.
Oh no, I messed it all up.
No, you didn't. You've just got to drop that one down a bit. This one just goes down. Okay? I'll let you stick